show that for small values of x, the square root of 1 minus x over 4 all divided by 1 plus x over 4 is equals to 1 minus x over 4 plus x squared over 32 approximately. Then by setting x to be 1 over 16 in above, determine root 63 over 65 correct to 4 decimal places. So how do we approximate a binomial problem with real powers? So in this case, we start by using the laws of indices. So when you have, for instance, root a over b, this is the same as root a over root b, then the laws of indices on fractional powers, this means square root, it means it is raised to power half over b raised to power half. Then the rule on fractional powers, this is the same as a raised to power half times 1 over b raised to power half. So we have a raised to power half, then the fractional power will now be b raised to power half raised to, you put the negative to show the reciprocal. So in this case, when we have the square root of 1 minus x over 4 over 1 plus x over 4, this is the same as root 1 minus x over 4 over root 1 plus x over 4. So that is going to be 1 minus x over 4 raised to power half over 1 plus x over 4 raised to power half, which is equivalent to 1 minus x over 4 to power half, then the one in the denominator, 1 plus x over 4 to power negative half. So we need to expand this binomial expansion and expand this binomial expansion. Now to expand to show that it is approximately this, meaning we expand up to the term x squared. So if you have a binomial expansion 1 plus y raised to power n, remember when you have n factorial, that is n into n minus 1 into n minus 2 into n minus 3 to the n. So the first term of this expansion is 0 factorial. When you have 0 factorial, it means there is no term in the numerator. So the numerator, there is no term, you only have 1 there. Then it means our y is raised to power this 0. Then plus the second term after 0 factorial, we have 1 factorial. So 1 factorial implies there's 1 term in the numerator, and that is 1 term, n. Then you have your y is raised to power that 1. Then plus 0 factorial, 1 factorial, 2 factorial means there are 2 terms in the numerator. So 2 terms in the numerator will be 1, 2. So that is n into n minus 1. Then our y is raised to power 2. So we will use this Maclaurin series expansion of the binomial expansion to expand the product of these two binomial expansion with real powers. So we have to expand up to the term x squared because that is the approximate value that is required. So what we have from our function now, we have square root we have the square root of 1 minus x over 4 over 1 plus x over 4 will simply be, you expand this first function, so we'll be expanding this first function. So if you expand this first function, it means our y in this first function, our y is minus x over 4, and our n is 1 over 2. So we expand this. Where there is y, we put negative x over 4 in this first one. Then where there is n, we put 1 over 2. So we'll have, remember 1 over 0 factorial is 1. 1 over 1 is 1. Any number raised to power 0 is 1. So the whole of this remains 1. Then n over factorial is n, y raised to power 1 is y. So the whole of that remain ny. So we substitute. So we have 1, we are dealing with this first one, plus n for the first one is a half times y for the first one is negative x over 2. Then it is plus n for this first one is a half into n minus 1. A half minus 1 is negative a half over 2 factorial. Then our y is negative x over 4 squared. Then that expansion, we multiply it with this second one. So this second one, you can see the second one here, y is positive x over 4 and n is negative 1 over 2. So if we expand this one, we have the first value is 1. Is 1 plus n times y. N for the second is negative a half. Then y is x over 4. Then plus n is negative a half into negative a half minus 1 is negative 3 over 2 over 2 factorial. Then our y is x over 4 squared. So if you find the product of these two functions, we will have, if we simplify them first, if we simplify this, we get the 1 a half times negative 1 over 4 is negative 1 over 8 times x. A half times negative a half, that is negative 1 over 4. Negative 1 over 4 squared is 1 over 16. Negative 1 over 4 times 1 over 16 divided by 2 factorial. That is negative 1 over 128x squared. Then you simplify the second one. If you simplify the second one, we have 1 plus negative a half times negative positive 1 over 4 is negative 1 over 8x. Then negative a half times negative 3 over 2, that is 3 over 4 divided by 2 is 3 over 8. 1 over 4 squared is 1 over 16. 3 over 8 times 1 over 16, that is 3 over 128. Then our x is squared. So the next step is now to multiply the two expanded factors. So when we are multiplying, we are only multiplying the cases where the power is higher than the exponent is higher than 2, we ignore. So we start with 1. 1 multiplies all the factors on the other side. So 1 times 1, you get 1. 1 times negative 8 over x, that is negative 1 over 8x. 1 times positive 3 over 128 x squared. So x squared is there, so we don't ignore that. We move to the next factor, is negative 1 over 8. Negative 1 over 8x times 1, we get negative 1 over 8x. Negative 1 over 8x times negative 1 over 8x. Negative times negative is positive. 1 over 8 times 1 over 8 is 1 over 64. X times x is x squared. Negative 1 over 8x times that, we get x times x squared is x cubed. So we ignore that because here we only want to reach x squared. So we are done with that. We move to the last term. Negative 1 over 128 x squared times 1, you get negative 1 over 128x squared. Then negative 1 over 28 times x squared times this, x squared times x will be x cubed. X cubed is not here, we ignore that. X squared times x squared will be x to the power 4, we ignore that. So we only need those. So if we simplify that, what do we get? So if we simplify this, here we have 1 minus 1 over 8x and minus 1 over 8x. That is minus 1 over 8x minus 1 over 8x. That is minus 2 over 8x. That is minus 1 over 4x, which is just x over negative x over 4. So here we have minus x over 4. We are done with this, this, and that. Then we join. The next, positive 3 over 128x squared, positive 1 over 64x squared, negative 1 over 128x squared. So if you factor out x squared, you remain with this. So 3 over 128 plus 1 over 164. 1 over 164 is 2 over 128. So 2 over 128 plus 3 over 128, 5 over 128 minus 1 over 128. That is 4 over 128. 4 over 128 is 1 over 32. So you have 1 over 32. So 1 over 32 times x squared, you get plus 1 over 32 x squared. So we've actually shown that when the value of x is very small, this is approximately this. Then after that, you've been told to use it to approximate the value of root 63 over 64 when x is negative 1 over 16. So when x is negative 1 over 16, you have here, we've found is 1 minus x over 4 plus x squared over 32. So we want when x is 1 over 16. So when there is x, you substitute 1 over 16. So this side will have square root of 1 minus 1 over 16 divided by 4 is 1 over 64 over 1 plus 1 over 64. 1 over 16 divided by 4 is 1 over 64. Is equals to 1 minus x is 1 over 16 divided by 4 is 1 over 64. Then plus 1 over 16 squared. There we have 1 over 16 squared divided by 32. So 1 over 16 squared is 1 over 16 times 1 over 16 divided by 32. Then you simplify. So 1 minus 1 over 64 is like 64 minus 1, 63 over 64. So that is root 63 over 64 divided by 1 plus 1 over 64 is 65 over 64. If you work out this in the calculator, you'll get 0.9845. So here, 64 goes with 64. So if you simplify, if 64 cancels with 64, you remain with root 63 over 65 to be 0.9845 to 4 decimal places. So if you simplify this with the calculator, 1 minus 1 over 64 plus this 1 over 16 squared divided by 32, you get that. So we've actually shown when the value of x is 1 over 16, then root 63 over 65 is approximately 0.9845.